What if I told you that everything you see, touch, and experience, every galaxy, star, planet, and atom, makes up less than 5% of reality? The world we live in, seemingly vast and complex, is just a fraction of what's actually out there. Welcome to the hidden universe, a mysterious realm that science is only beginning to uncover, a universe so bizarre and elusive that it defies the very laws of physics as we know them. Buckle up, because we're diving into the most astounding cosmic mystery humanity has ever faced. The reality that 95% of the universe is invisible, unknown, and profoundly strange. Let's start by asking the big question. What exactly is the rest of the universe made of if not ordinary matter? Scientists call these elusive substances dark matter and dark energy. They are dark not because they emit no light but because we have no direct way of detecting them, yet their existence is unmistakably imprinted on the cosmos itself. Our journey begins with dark matter, a ghostly form of matter that makes up approximately 27% of the universe. This invisible substance doesn't emit, absorb, or reflect light, making it incredibly challenging to detect. Yet dark matter's existence is undeniable because of its gravitational effects. Picture galaxies spinning at incredible speeds, far too fast to be held together by the visible matter alone. Without something hidden, galaxies should fling themselves apart, scattering stars into the void, but they don't. They remain intact, rotating gracefully. Why? The answer: dark matter. Scientists first suspected dark matter in the 1930s when astronomer Fritz Zwicky noticed galaxies within galaxy clusters moving too quickly to be held by visible matter alone. Then, in the 1970s, astronomer Vera Rubin observed that stars on the outskirts of galaxies rotated just as fast as stars near the center, something impossible without extra, unseen mass holding everything together. These discoveries shook physics to its core, forcing scientists to accept the existence of something invisible yet overwhelmingly influential. But what exactly is dark matter? Theories range wildly, from weakly interacting massive particles or WIMPs which pass silently through regular matter, to axions, particles so faint they barely interact with the world around us. Despite elaborate experiments buried deep underground to avoid cosmic interference, direct evidence of dark matter continues to elude scientists. This mystery, just deepens the intrigue and urgency of discovery. Dark matter could fundamentally rewrite physics, introducing entirely new particles and fields of science we can't yet imagine. If dark matter is strange, then dark energy, the force making up a whopping 68% of the universe, is even stranger. Imagine a force so powerful it defies gravity, pushing galaxies apart at ever-increasing speeds. Dark energy isn't just expanding the universe, it's accelerating its expansion, driving galaxies further and further away from one another. This phenomenon was actually discovered accidentally in the 1990s by astronomers observing distant supernovae, who expected to see the expansion of the universe slowing down due to gravity. Instead, they found exactly the opposite, an accelerating expansion, driven by an unknown, unseen energy. The implications are staggering. Eventually, galaxies will recede from each other so quickly they'll disappear from our view entirely, leaving future astronomers staring into an empty, starless void. But what exactly is dark energy? Physicists are still wrestling with this question. One leading hypothesis involves the concept of vacuum energy, essentially energy intrinsic to space itself. Imagine space not as empty nothingness but as a vibrant quantum field bubbling with virtual particles popping in and out of existence. This quantum foam could generate enough repulsive force to drive the accelerated expansion of the cosmos. Yet another possibility is that, our understanding of gravity itself is flawed. Perhaps Einstein's theory of general relativity, which beautifully describes gravity on cosmic scales, is actually incomplete. Modified theories of gravity like F of R gravity or modified Newtonian dynamics, often called MOND, suggest we need new physics to explain cosmic phenomena without invoking mysterious dark entities. Still, these theories struggle to match observations as neatly as the dark matter and dark energy models. The hunt for answers pushes technology and imagination to, new limits. From colossal particle colliders like CERN's Large Hadron Collider to deep space observatories such as the James Webb Space Telescope, humanity is expanding its scientific capabilities to truly unprecedented scales. We're building gigantic underground detectors, using entire planets as instruments, and even deploying telescopes to the far side of the moon, all in the pursuit of understanding what this hidden universe is really made of. Imagine the moment we finally uncover dark matter or dark energy. Such discoveries would honestly revolutionize physics, comparable to Einstein's relativity or Newton's laws. We might unlock technologies we can't even dream of today, like anti-gravity propulsion, limitless clean energy, or even ways to manipulate space-time itself. The possibilities are, without a doubt, boundless and tantalizing. Yet for now, the hidden universe remains stubbornly out of reach, silently challenging humanity to unravel its mysteries. It reminds us of the limitations of our current knowledge while simultaneously inviting us to expand our scientific horizons. We stand at the brink of discovery, peering into the abyss of the unknown, knowing that the answers we seek could redefine reality itself. So, the next time you look up at the night sky, remember, what you're seeing is just a tiny fragment of reality. Behind every star, every galaxy, every photon of light lies a hidden universe waiting patiently to be revealed. 95% of reality isn't just unknown, it's unimaginable, and discovering what it's made of might be humanity's greatest adventure yet. Scientists worldwide are passionately engaged in the quest to detect and understand dark matter and dark energy, crafting meticulous experiments designed to tease out even the faintest hints of their existence. Imagine underground laboratories, deep beneath mountains and hidden from cosmic rays, where sensitive detectors await the elusive whisper of dark matter particles. These experiments are technological marvels, vast chambers filled with liquid xenon or germanium crystals, cooled to temperatures colder than deep space, meticulously monitored for interactions so subtle they might only happen once in a decade. Yet, despite these monumental efforts, dark matter continues to dodge our best attempts at detection. This stubborn invisibility has led some physicists to propose that dark matter might not even be composed of particles as we traditionally understand them. One fascinating alternative is that dark matter could consist of primordial black holes. Tiny black holes formed immediately after the Big Bang, each with masses far less than that of a typical star. These minuscule black holes could drift undetected through space, exerting gravitational influence but leaving virtually no other trace. If confirmed, this would not only solve the dark matter mystery, but would also offer breathtaking insights into conditions immediately after the universe's birth. But as captivating as dark matter is, dark energy remains an even more perplexing enigma. Its discovery forced cosmologists to reconsider the fate of the universe itself. Before the detection of dark energy, astronomers debated two main possibilities for the universe's ultimate destiny. Either it would slow down its expansion and eventually collapse back into a big crunch, or expand forever at a gradually decreasing rate. However, dark energy introduced a third, more startling scenario, a universe that expands forever at an ever-accelerating pace, eventually becoming cold, empty, and isolated. This scenario leads to what scientists chillingly call the Big Freeze or the heat death of the universe. Picture a distant future, billions of years from now, where galaxies beyond our local group are rushing away faster than the speed of light due to the expansion of space itself. The night sky, once a tapestry of glittering stars and distant galaxies, becomes emptier with each passing eon. Stars exhaust their fuel, extinguish one by one, and no new stars form because galaxies drift too far apart. Eventually, even black holes evaporate through a quantum process known as Hawking radiation, leaving nothing but a vast, dark emptiness. Faced with such profound mysteries, some physicists speculate that dark energy and dark matter might hint at entirely new realms of physics, maybe even additional dimensions beyond the four, that is, 3 spatial dimensions plus time, that we experience. String theory, which is one of modern physics' most ambitious frameworks, suggests that reality could contain as many as 11 dimensions. In these hidden dimensions, forces like gravity might behave very differently, possibly explaining why dark matter interacts so weakly with ordinary matter. Consider another groundbreaking hypothesis, the multiverse. This provocative idea proposes that our universe is just one of an infinite number of universes, each with different laws of physics. Within this grand cosmic landscape, dark energy could simply be an environmental condition unique to our universe, one among countless variations scattered across an unimaginably vast multiverse. If true, this raises profound philosophical questions. Are we living in one of the rare universes suitable for life? Could the peculiar characteristics of dark matter and dark energy actually be fine-tuned parameters necessary for our existence? To investigate these radical ideas, astronomers and physicists are planning ever more ambitious missions and experiments. Future space observatories like ESA's Euclid satellite and NASA's Nancy Grace Roman Space Telescope aim to map billions of galaxies, tracing cosmic expansion with unprecedented precision. These missions promise not only to refine measurements of dark energy's behavior, but also to test alternative theories of gravity and cosmology. Back on Earth, particle physicists are proposing the construction of even larger colliders successors to the Large Hadron Collider, designed explicitly to search for signs of dark matter particles. The envisioned Future Circular Collider, or FCC, would stretch for a staggering 100 kilometers beneath Europe, smashing particles together at energies unimaginable just decades ago. Such ambitious endeavors could finally reveal elusive particles or entirely new phenomena that clarify what dark matter truly is. But as advanced as these scientific pursuits become, there's always the thrilling possibility of surprises. History teaches us that nature often defies expectation, delivering revelations that shift paradigms entirely. Perhaps the answers won't come from massive laboratories or orbiting telescopes, but from some unexpected direction, an anomaly in data, an unforeseen celestial event, or even from the brilliant insight of a single individual working quietly in obscurity. Indeed, humanity's exploration of the hidden universe is a testament to curiosity and resilience. Each new discovery not only solves mysteries but opens doors to deeper questions, reminding us that the universe continually expands our capacity for wonder and humility. As we stand at the frontier of knowledge, the invisible cosmos beckons us forward, daring us to stretch our imagination further and deeper. The hidden universe serves as a profound reminder that humanity's understanding is still in its infancy. We are explorers on a grand cosmic ocean, peering into darkness illuminated only by our curiosity and ingenuity. Every galaxy mapped, every particle discovered, and every theory tested brings us incrementally closer to deciphering the hidden fabric of reality. Imagine a future where we fully understand dark matter and harness dark energy. The technological possibilities would be transformative. Dark matter, once understood, might revolutionize how we perceive and interact with mass and gravity. Dark energy could become a source of limitless power, reshaping civilization itself. The universe, in all its hidden complexity, could provide tools that today belong solely to the realm of science fiction. Ultimately, the quest to unravel the hidden universe is more than scientific curiosity. It's a journey into the very essence of existence. It's an invitation to reflect on our place in the cosmos, acknowledging the humbling truth that the universe we know is but a whisper in a grand symphony of reality. And perhaps in this exploration, humanity will find not only the secrets of the universe but also a deeper understanding of ourselves and our potential. The next great leap in human knowledge awaits us, hidden just beyond the veil of perception. We may only perceive 5% of reality, but within the unseen, 95% lies an adventure that could reshape our civilization forever.